All right, back. So this is as far as we got previously. We just had sort of the overall geometry set up. So what I'm going to do in this part is start to define the material properties for those steel rods and the timber beam. So just to pull up the assignment again. So the beam is going to be made out of timber with that cross section 500 by 100. We're given this E value of 15 gigapascals. We're also given a density of 510 kilograms per meter cubed. For this particular assignment, this is going to come into play when you're calculating your distributed loads on the beam. For the purposes of modeling in SAP, I'm not going to include the self-weight, so we don't need to worry about trying to implement that density for the purposes of this going through this particular problem. Okay, for the rods, it's a circular cross section with a diameter of 25 millimeters, and we've got kind of the standard E value for steel of 200 gigapascals. Okay, let's go into SAP, and what I want to do is define a couple of new sections to deal with these two different types of sections. So first thing I'm going to do is actually go into materials, because timber is not one of the default materials. So what I'm going to do is add a new material. Material name, I'll call it timber. To make it easier, call it wood, whatever you want. Type of design, this doesn't really matter, but we just put other, and that kind of cancels things out. You can see all sorts of different things in here. The big one for our purposes will be the modulus of elasticity. So you can see that there are different default values for mass per unit volume, weights, modulus elasticity, Poisson's ratio, coefficient of thermal expansion, shear moduli. But in this problem, what I'm specifically want to change and make sure it's consistent with my problem is the modulus of elasticity. The reason being, these other things are, well, for example, I'm not looking at temperature change in this problem, so coefficient of thermal expansion isn't coming into play. And then I'm going to turn off the self-weight. I'm going to just implement that in my distributed loading in the assignment. So this mass per unit volume and weight per unit volume are not going to be relevant for this particular problem. So I can just leave them as default values. But the modulus of elasticity, I do want to change. Okay, we were given 15 gigapascals as the E value. I'm going to write in 15 e to the 6 for my modulus value, and I'm going to explain why I am using that in a second. But I'll put that in now, and then I'll hit OK, and then OK here. All right, now, how did I know that was the value to put in? Let me go back here. And let me get some space. The units okay, so we've got an E value in this problem for our timber, 15 gigapascals. 15 gigapascals is equivalent to 15 times 10 to the 9 pascals. If we go back to SAP, I'll pull this up. If you look in the right corner, my units are kilonewtons and meters. So E, remember, is in units of stress. Okay, but if I'm using units of kilonewtons and meters, okay, kilonewtons, and that will be meters squared to get my area, that would be equivalent to kPa. So my E values should be given in units of kilopascals. So that 15 gigapascals, then converting that to kilopascals should be 15 times 10 to the 6 kPa. Because basically there are going to be 1,000 pascals in 1 kilopascal. So that's why I input that as 15 times 10 to the 6. Okay, so that is my E value for that. The other materials, so the rods are made out of steel, and there's already a default value for steel in there, so we can just go along with that. What I'm going to do now is define some sections, some frame sections. So I'm going to open this up, click on that, and there's obviously this default one, but what I'm going to do is add, well, for the timber beam, I'm going to add a rectangle. So there we go. Let me call this the beam. And I want to switch out the material to this new timber that I defined. And here's our cross section. So I want this to be consistent with the cross section of my real beam. Remember, we're dealing in units of meters. So 500 millimeters will be 0.5 meters. And the width of this is 100 millimeters. That's 0.1 meters. So that's my beam cross section then defined. So I'll click OK. And then I'm going to, for the rods, I'm going to add a circle. I'll call this whatever you want, rods. Okay, it's got steel, so that's good. And then I'm going to change that diameter to, again, we're in meters, so it's 25 millimeter diameter, so 0.025 I think should give me the right diameter. Click OK, and now I've got these two frame sections defined along with the materials, so I click OK, I'm good to go. What I'm going to do now is click this, and I'm going to go to Assign and Frame Sections. I want to make these beam sections. So I make sure the beam is lit up. I click OK. There, got the little note on there that those two have been defined as beams. I'll click the 3 rods. Clickety click, click again. So they turn dash. That confirms that they have been selected. And then I'm going to go to Assign Frame Sections. For these ones, I want the rods. I click OK, and there we go. So now I have the correct material properties for those, for the beam and the rods, and I've also correctly defined their cross section. So the last little bit is to actually apply the loads to this thing, and let me do this in part 3. So see you then.